So let's talk a little bit about electrolytes. Electrolytes are substances that produce an electrically conducting solution when they're dissolved in a polar solvent like water. Okay, so the dissolved electrolyte is going to separate into cations and anions, and those cations and anions kind of spread out through the solution. So an electrolyte is something that's going to make ions when it's dissolved in water, and those ions can conduct electricity. The more ions you have, the better conductor your solution will be, and the stronger the electrolyte. So we'll see that we have strong electrolytes, weak electrolytes, and non-electrolytes. So this isn't really about what we're going to do in chemistry, but just to give you an idea what the heck are electrolytes, because you've heard of electrolytes, right? You've had Powerade and Gatorade, right? So electrolytes regulate the fluid levels in your blood plasma. Okay, they keep your pH in a normal range, and this is where kind of the sports comes in. They enable muscle contractions. They allow the beating of your heart. Okay, and there's a lot of nerve signals here from the heart, the muscle, and the nerve cells. So if you're low on electrolytes, some of these things don't happen very well. So what's a strong electrolyte? Well, a strong electrolyte is a solute, that's the thing we dissolve, that ionizes or dissociates completely. We're going to say pretty close to 100%. Okay, so you get lots of ions and you get very good conductors. Some examples of strong electrolytes are strong acids like HCl, H2SO4, and HNO3. Strong bases like sodium hydroxide and potassium hydroxide and lithium oxide. And then any ionic compounds that are soluble. Okay, so you can use your solubility rules, but sodium chloride, barium nitrate, potassium phosphate. Okay, if I had a 1 molar solution of each of these, they wouldn't conduct electricity equally. This makes 2 ions, this makes 3 ions, and this makes 4 ions. So the potassium phosphate would actually be the better conducting solution because it has more ions to do the conducting. We also have what are called weak electrolytes. So they're going to conduct electricity, but they're not going to conduct electricity very well. Electrolytes, the weak electrolytes, only kind of dissociate somewhere between like 1 and 10%. That's kind of a general rule. So they'll conduct electricity weakly. So weak electrolytes are things like weak acids, weak bases, and also pure water. Okay, so just plain old pure water with nothing dissolved. So we're not talking about an ocean or a lake or your swimming pool, just pure water. The water was going to ionize into H plus and OH minus. Write that a little better. But H plus and OH minus only exist about 1 times 10 to the minus 7 molar. So they have very, very few ions. It's almost entirely this. Okay, so it will conduct electricity, but only a teeny tiny bit. When we think about water conducting electricity, we're actually thinking about water with stuff dissolved in it. So we also have what are called non-electrolytes. These are substances that when you dissolve, they don't ionize because they don't have any ions to ionize into. So these are going to be very poor or non-conductors of electricity. These are things that are, basically these are going to be your molecular compounds. Okay, so things like sugar, and then also alcohols. Alcohols are going to be a group of compounds you're going to see that look a little like bases, but they're not. Okay, this is methanol, this is ethanol. Okay, they end in OH, but the difference between an alcohol and a base is the first part. Okay, sodium hydroxide, lithium hydroxide. When the first part is a metal, these are bases, okay? When the first part is a bunch of hydrogens and carbons, these are alcohols. So you'll need to be able to distinguish between those when you're trying to figure out between strong electrolytes and non-electrolytes. So if you were to look at a demonstration, a pretty common demonstration in a chemistry classroom is to use a light bulb, and you stick it you just plug the light bulb into an outlet, and you have two electrodes that you put into your solution. So something like ethanol, which we just looked at, which is an alcohol, okay, that's going to be a molecular compound, so a non-electrolyte, so you don't see the light bulb light up at all, okay? On the other hand, you're going to see KCl, which is an ionic compound. It's going to form a lot of ions, and you're going to have a nice bright light bulb here, okay? It's going to be very, very bright. And somewhere in between, right, acetic acid, that's your weak acid. So that's going to be a weak electrolyte. So you'll see that it lights the light bulb kind of weakly. Okay, you might say that the light bulb is dim. So that's the difference between strong, weak, and non-electrolytes.